Dr. Michel Joop, and is a postdoc here at PUB, and he will talk about a sustainable design of robots. So, if you're okay, the
yes,
floor is yours. Yeah, just some moments. Is it okay? Okay, the floor is yours.
Okay, I'll just use the keyboard. It's fine. Okay, so last presentation. I hope I won't torment you too much with theoretical input, but I'll have some pictures, and I want to jump right in. Oh, sorry. Jump right into my topic, sustainability in the design of urban service robots. So urban service robots was our use case, but you could probably put automotive or not automotive, autonomous systems in that place as well. From the motivation or like the intro, what motivated me a bit was this book or the section from this book that I can just read to you and signify which is the most important for me. No one would seriously argue that technological developments cannot bring about progress for society. However, if a discourse on technological developments were to remain solely at the application level, the question of technical feasibility, it would lose sight of the profound influence that technological developments have on the constitution of a society and how they also change the human condition and the entire social arrangement of people. It was translated from German, so it's a bit not so, or it doesn't read so nice as in German, I would say. This is the important part. I don't know if you can see it. Yeah, it's a bit in yellow. So we know the innovation and the technical developments very well, and we had a lot of talks on very specific technologies. For me, it's really important to look at the part of society and all the impacts that technology has on that part. So I was trying to look into that due to a project and just a few impacts that I see or that you have in the socioeconomic dimension, I would say. Here we see the 5, I put the 5th already, although it's in the future, the 5 industrial revolutions. So we know that machines or robots can influence society and the economic a lot. And we've seen this throughout the years, and there's been a lot of studies also on it. What does it change? How does the labor market change? How does the work change? The quality, the quantity, etc. So those are a lot of impacts that we can look at. We're all aware of the ecological impacts. We have the resource extraction that causes some trouble. We have the energy demand that those machines cause. So we have a lot of energy consumption, energy production that is not always green, as we know. For example, the nuclear waste is one of the problems. And then also end of life, which is depicted here in the bottom pictures. There's a lot of waste depots in Africa and Asia, where a lot of the trash goes that we have here in Europe produced and used, and then it gets shipped over there, and it causes not only economic problems or environmental problems, but also social problems, as you can see from those pictures. So those are just the impacts, the possible impacts I want to look at, or I want to focus more on the during the design process. And we have here the Sustainable Development Goals by the UN, and here they are in a wedding cake, I think that's called, or this picture is called wedding cake, where you have the 3 different dimensions. Here it's called biosphere, society, and economy. Sometimes it's referred to ecology, society, and economy. And we see the different goals sorted to those 3 dimensions. It's not always very easy because some of those goals really belong to more dimensions than just one, but it's just an example of the different goals or the different key aspects and indicators that we could look at. So then we have robotics advancing a bit more from what I would say is the industrial robot to the service robot, or the robots that are out in public, out in the streets, that can be in elderly care homes. And so it does change really from a environment where the robots are more confined to a certain space to a space that is more open, more public. And the interaction with humans then is more, it's like in the industrial robot, it's tried to be avoided. And then in the public world, it's like one of the actual traits of the robots. So there's really more interaction with humans, and so more impacts on the society level that you can really look at, or that you have to look at. I was looking, oh, yeah, I'm missing that point. I was looking a bit into the actual research focus for urban service robots as of now, and you can see a lot of functions that are looked at. So this diagram I can explain a bit is the size of the circle means how much research papers were found on it, and then the size of the line between those circles is how much research papers were found with a combination of those two. And you can see a lot is about navigation and sensing. Wait a second, I'll put up a digital laser pointer. So you can see it's a lot about this navigation and sensing and perception, then a bit of communication, and those 3 points here are a bit lower. But mostly this is just technical innovation and not really any topics in terms of sustainability, social or ecological aspects. So there's really a lack of coalescence of robotics and sustainability, which was also shown in a lot of, or a few papers and studies that had been made. Also, I think from Fari and from Bram here during some of the bigger conferences on robotics. So there's really like a lack or a gap. And I try to fix that, or I try to suggest something, a methodology to actually come up with some ideas to integrate more these aspects of social and ecological dimensions of sustainability. So the interest really is what methods or method can be used to integrate those aspects. And I took 3 questions that I wanted to solve in this. So how to integrate goals for sustainability, how to assess the attainment of those goals. So first you have to bring it into the design process, and then you have to also assess and see if those goals are attained or not. And then third, more like a meta level, how does this approach affect the design process itself? And I think on the next slide, no, not this one, but one of the next slides, I will try to explain a bit more the development process, because I think you might not be familiar to that. And for me, it was like a thing that I did for the last 6 years. So I'm really like thinking on all those words, and probably really easy for me, but you might not be knowing what I'm talking about. So I'll have some pictures to show you later. The approach to solve those questions were connected with a project. I called it Marble. In German, translates from German to English. German would be Murmel. It's the marble in German. And it is a robot to help the municipality in Berlin, the city of Berlin in Germany, with the waste management. It has there's bins on the street, and we wanted to have a robot that empties those bins and helps the collection of waste. So we analyzed first research existing methods, so what is out there. We tried to apply it to the project, and then we had some feedback, and then we evaluated this feedback and built the methodology in that way. So again, for the project, it stands for Mobile Autonomous Robot for Litter Emptying, and we tried to lower the CO2 emission in the public service sector. So it was like one of the primary goals, because for now the process is really heavily dominated by diesel cars, and we try to replace that by electronical robots. The motivation was also to support and improve the process itself, so make it more efficient, because there's a lot of waste in Berlin. There's a lot of people on the streets. The trash bins sometimes get overflowed or they break. And the municipality has to fight that, and they don't have enough people. So we really try to also support and improve the process itself, and do that in all the three dimensions of sustainability. So more efficiency in terms of the process and the service that we could deliver, more ecological sustainable by not using diesel cars, and also maybe social sustainability in terms of alleviating physical straining tasks. Just to give you a little picture of the robot itself, because I was just revising the presentation and I saw that I don't really had a lot of pictures of the robot itself in it. So on the left top, you can see the CAD model that we had. On the right, you see the robot itself, and at the bottom left, it's again the robot. It's like the final version that we used out on the street. And then on the right, we have a design study that was made for surveys to kind of create an idea how the robot could look like in the future as like a real product. So this was all the functional prototype to really show the feasibility, and then this was kind of an idea how it might look like in the future. So I will start with the methodology, and I just have 2 slides for that. The first thing is we did a synthesis, as I said, of a specific product design process. So there's a very general product design process where you have different tasks that you go through. You iterate through them, so they're not really sequential, but you iterate through them depending on your design stage or phase. And then you have, on the other hand, results. And that is a general one, and you can also try to make your own specific product design process and use process knowledge and contextual factors. So contextual factors were here the SDGs, sustainability, and the process knowledge came from the project that we had. And so we added some new activities, some new results, and some new objectives. And it looks like this in the end. So as I said, we have activities on that side. You don't need to like read through all of them. It's just to show you the model itself. And this is the phase. So I always say that we're in an early concept design phase, because we're really there from the beginning and we're doing a first prototype. So we're gathering requirements, doing a first feasibility and functional prototyping, and really trying to have like a first prototype out there to go on from there. So the very new thing that I introduced or suggested was this preliminary social assessment, which has 4 different steps. I will go into that a bit further. And I changed or added a few things in those blue activities here. And as I said, it's not really like a sequential thing, but you go through it iteratively. As you see, those blocks stand for we had this activity in the first place, then we went to the next, but then repeated that. And so you see they're all intertwined in each other. Again, this is like really overloading information, but those are 2 checklists that I created from the project and from different sources in literature to kind of set up a checklist, one for the social and one for the ecological sustainability, that you could use as a designer or an engineer, that as soon as you want to develop a robot or an urban service robot, you can look at those checklists and try to like go through them and see if any of those points are relevant for you. So for instance, society, we have worker, society, and consumer. On the side of activities by or with the product, that means the use phase of the robot. So this is all a bit, you could say life cycle engineering. You have the different phases of the product, and it's all sorted by those life cycle phases. So here for the society, for instance, comply with the general data protection regulation, which is obvious, but just all of those different bullet points you could go through and check or see if that applies to your project. And the more interesting one is this one. I call it the, as I said, preliminary social assessment, or short PSA. I also went through the presentation, and I felt maybe it's just the engineers from my department that like abbreviations, but we do have them. So it's the PSA. I will in future only talk of the PSA. And we have 4 different steps. And the first one is pretty much the same as you would use in every development process, that we just do an analysis of the environment and the function of the product. So not the environment in ecological sustainability, but the environment or the system that is around the robot, all the processes, stakeholders, etc. The second step then is a social impact and risk analysis, which refers to a guideline where we have different key aspects that we can look at. It's quality and quantity of work. It is hostile environments, and it's also accessibility and equality. And there you kind of rate your first idea or your first concept and see in what areas is the risk of trespassing the social sustainability and endangering maybe any stakeholders. And going from there, when you know, or when you estimated what is like a problem, what could be a problem, you try to implement that into your scenario and design creation. Design creation would mean doing any prototypes, could be functional prototypes, could be, as we did, the design studies or a picture, anything that makes stakeholders understand what you want to do with your robot. And also the scenarios, you create scenarios in which you put the robot so that you can really put the robot into a context and tell the stakeholders what the robot will do, where it might affect them. And as soon as you have that, you can really talk and discuss with the stakeholders how they would accept it, what they like, what they dislike. So a sort of validation of needs, as I called the 4th step. So, okay, this is a bit broken, I'm sorry. Those are the 4 steps again, as I just mentioned, and I have some nice pictures for it as well. So here you see the system that you have to analyze. This is the social impact and risk analysis, the SIRA, with the different key aspects. It's 10 key indicators. Scenario and design creation, as I said, you just also can look into the future. One important step of design and or scenario creation is trying to imagine your product in 10 or 5 years, because you're developing a robot now, and if you are really at the beginning, you know the robot will take about 5 to maybe 10 years really to be at a stage where you can implement it. So you have to look into the future, look at trends, and see what will change in the next 5 or 10 years, to not develop a robot for now, but to develop a robot for in 10 years. There could be trends in society, there could be trends in law, there could be trends in the city, the infrastructure, etc., etc. So it's really important also to look at that and derive requirements from the future, so to say. And the last one is more of a workshop survey interview thing, where you really interact with your stakeholders to see, do I meet the needs with the robot? Is there other needs that I didn't think of? Is there more functions that I need to implement, or are those functions that I thought of maybe too much? Yeah, those 4. And then the last step is the assessment. So, sorry, one too many. Assessment is really hard in terms of the qualitative aspects. We have a lot of quantitative aspects that we can measure, which are also not easy, but we can measure them and we can put in numbers in sort of a perspective. But the qualitative measurement is really hard, and we try to do it a bit via surveys, where you try to really gather a lot of people together. I think we had 1,000 people that were answering the surveys. So you try to make like a little quantitative measurement in the end, saying, okay, 80% said yes to this, or chose this design over the other design. So you can try to evaluate it a bit more, but you always have to describe the outcome with a text or with more than just a number, because if you only put numbers in, you're always in danger of losing really the content of the aspect itself. So yeah, one is the scaling, and the other is a verbally descriptive value function that you can use. Then there's also the determination in the information and determination of information values. So you have to gather really your data from the project and from the stakeholders. And as I said, we did that with surveys. We did that with workshops and interviews on the social dimension, and then we had a lot of life cycle engineering assessments, so LCA and SLCA, that you can use for gathering information about the aspect of GWP, so the global warming potential. How much CO2 emission will your production, your extraction of resources, your use phase, etc., produce? How much will that acidify water, seawater, etc.? So there's a lot of key indicators that you can look at. So life cycle engineering methods, and the one that I just suggested, the PSA. Okay. Also, very interesting statistical evaluation of those surveys, where you can try to correlate acceptance to other topics and then try to make a prioritization of different topics that you want to address in your development. Because the idea is always to derive from all the information that you get a new prototype. So you really want to weave in the information that you get, the feedback that you get, into your new design when you're on the next level or in the second prototyping phase. Yes, normalizing factors as well. That's more for the quantitative measurements. And yes, so far that's for the methodology. And just to give you a short input on results, this is a life cycle assessment analysis. So you will look into here just the emission of CO2. And we had 3 different scenarios. We had 2 scenarios with the robot, and then 1 scenario without the robot, which is on the far right here. And we also did it for now and for in the future. And then you can see big differences in all those scenarios, because here we have the diesel still, the diesel cars. So the operation is really taking up a big chunk of the CO2 emission. And then here we have ideally the whole fleet of that municipality as electrical vehicles, and then they take up a lot less. And you can also see it's less than this scenario here, but it's not like significantly less, so you could say it's equally distributed. And also, maybe to clarify that, this big gap here from 2023 to 2030 also includes that we think, or that we hope, that we will produce about 80% of the energy in renewable energies. So that's one of the premises. We also had the workshops and surveys. As I said, we put our robot on the street, and we try to ask people that pass by and try to ask them what they think, how they react to the robot, and take notes, and also hand out the survey. And then we had workshops in our labs with the workers on different levels, and mostly it was really positive. A lot of people liked the robot, and they were not really they knew it was a robot that was in like a prototyping phase. We try to tell them that it will really develop and not be that slow, because everybody was like, oh, it's really nice, but it's so slow. It's like, yes, we know, it's just coming on. It's a technical or functional prototype, but apart from that, most of the people were really positive and accepting of the technology. Also, the workers, they were really open for cooperation with the Marble robot. They thought it really could help in supporting physical training tasks, also making it more accessible to older workers, or, as they said, female workers that don't like heavy lifting. That was just like I'm quoting here. But they also had some issues. They thought this might be overburdening them by technical complexity and also by the thought of having the responsibility for cost-intensive equipment when you're working with the robot. And another one was always fear of being replaced by automation. That is something that you can't get out of their heads. It's always there. They always mention it. They knew that it would probably not happen because they have a really strong union that doesn't allow any automation that replaces work. So they're kind of safe, but they still have this fear in their heads, and you have to really talk about it with them. And I think one of the biggest outcomes from the workshops would be for me that at the end of the workshops, everybody said it's so nice to be involved in the design process. They weren't left out. They were taken seriously. We took their all their voices into account. We discussed everything with them, and they really liked this transparent way of development and design. And I think that was really a huge push to, or can be a huge push to acceptance of technology when you do it in a more democratic way, I would say. Lastly, the effect on the design process. I think as you now saw, one of the main issues is really the increased effort due to the use of methods. So the lifecycle engineering takes a lot of time. You have to build up simulations, you have to build up the systems, you have to gather a lot of data, which takes a lot of time, and also personnel that is specially trained in those methods. The project coordination becomes a bit more complex because you have more people from different disciplines, and also you have additional potential for conflict, because I think in a usual normal engineering process, you always have requirements that are contradictory and you have already some conflict. But if you put in the 3 dimensions of sustainability, you add a lot of more potential because some of them really don't go well together. On the good side, you could say you have an increased understanding of the whole product and system, and the conflict resolution could be done in the early development phases. And usually you say in the early development phase, you have a lot of leeway and it doesn't cost that much. So if the product is closer to finishing, if you have to change something, then it's really cost inefficient. So it costs a lot and it will take a lot of time to tweak the product. If the product is really at the beginning of its development phase, it's way easier and way cheaper to change the concept itself. Yeah, thank you for your attention. I hope I didn't bore you too much with this methodology. And now any questions from your side? Thanks.
Thank you, Michel. I think we have time just for a very short question. Or yeah, for sure we will have time.
Thank you. Yeah, I think indeed it takes a lot of time to do so, but it's also the first time that it's done. And maybe some things can kind of be automated. It's like now everyone needs to assess the eco score of his or her home. And that's also a very long list, but now also tools exist to not to automate it, but yeah, that you can select parameters. And so maybe that can also be in the future for robots that, yeah, these analyzes with all the aspects, yeah, that you don't need to find all the data, but you can select what is available and not, for example.
Yeah, and we had a lot of overlay actually from the different approaches. We had a life cycle analysis for the ecological part. We had a social life cycle analysis for the social part, and the life cycle costing for the economic part. And for all those 3, we did them differently, and one in year 2, one in year 3. For all those 3, you do the same steps in the beginning. So you could streamline that a lot, I think, and also take from the CAD model that I showed you. You can have like the item list and all the materials and the weight, and you can kind of, yeah, I think automate that a bit and streamline it more. Of course, yeah, there's potential.
Okay, I think that we can discuss later on. I would like to thank again all the speakers, and so see you next Thursday. Yeah, for the 6th appointment.
Goodbye.
Yeah.